Mr. McDesmos is back, and we're playing 3 holes of golf. Probability that he hits the green in regulation on any hole is 11 on 20 and is independent of whether he hits the green in regulation on the previous hole. Create a probability distribution for this situation. Okay, definitely go back and watch the previous video on Bernoulli trials because the binomial distribution is just repeated Bernoulli trials. So definitely go back and watch that. One thing to take away from that will be that Bernoulli trial is just this idea that one of two things happens. It's either a success or a failure. It's what's called a binary variable. So in this case, hitting the green in regulation has a probability of success of 11 on 20. So therefore, the probability of not hitting the green in regulation must be 9 on 20 because it either happens or it doesn't. So create a probability distribution for this situation. What we're going to start with is by making a tree diagram. So if we make a tree diagram, it's going to look something like this. When the first hole is played, you either hit the green in regulation or you don't. So we're going to say green is hitting the green in regulation. Red is you missed the green in regulation. And then you're going to do it again. So you're going to either hit it or not hit it. Hit it, not hit it. And then you're going to do it. So that's for the second hole. And then you play the third hole and you either hit it or you don't hit it. So what you get is a situation that looks like this in terms of a tree diagram. And then what we can do is we can put all the probabilities along there. So we can see that the probability of success is 11 on 20. So all these green lines have a probability of 11 on 20. And the other thing to mention as well is that they're independent events. So it mentions that here. Whether you hit the green in regulation the first time doesn't affect whether you hit the green in regulation the next time. So you get a tree diagram that looks like this. And then all the red lines must have a probability of 9 on 20. So that's the probability of not hitting the green in regulation. So now what we might want to do is work out across those 3 holes, what's the probability of x being 0. So capital X is our discrete random variable, and that can take on different values. Those different values of x we're going to call lowercase x. And so capital X equaling 0 would represent the situation where no greens are hit in regulation. So in all 3 holes that get played, all the greens are missed in regulation. So what we get here is we'd be down this side of the branch of our tree diagram. We'd miss, then we'd miss again on the second hole, then we'd miss again on the third hole. And so what we say is the probability that x equals 0, so we have no successes, is 9 on 20 multiplied by 9 on 20 multiplied by 9 on 20. A quicker way to say that is to say 9 on 20 cubed. Okay, but we need to unpack this a little bit more. There's actually a bit more going on here than at what seems to be the case at first. And let me explain. What we have here is basically an example of what's called the binomial distribution. So this 3 sort of over 0 is a function in maths called choose. So we would say 3 choose 0. Think about it like this. This is just a way of saying how many ways could Mr. McDesmos have gotten no successes? Well, there's only one way to do it. You have to miss every time. So from the 3 trials we ran, or the 3 holes we played, none of them were a success. And 3 choose 0 is 1. And that should make sense. There's one way to get no successes. Okay, what we do then is we multiply that by 11 on 20. So that's the probability of success raised to the power of 0 because we had no successes. We didn't go down any of these green branches. So multiply by 11 on 20 to the 0, and then multiply by 9 on 20 to the power of 3, which is what we have here. And that gives us an answer of 0.091 approximately, if you chuck it in a calculator. Now, I'll just point out these first 2 fractions are just the number 1. 3 choose 0 is 1. 11 choose 20 to the power of 0 is 1, because anything to the power of 0 is 1. So that is the situation where no successes are had. So you went down this branch. Okay. Next one. Now, what's the probability we have 1 success? Let's have a think. To get exactly 1 success, there's a few different situations. I hit the green in regulation on the first hole, and then I mustn't have hit it on the green in regulation on the second hole. And on the third hole, also missed. Okay, or I could have gone miss, hit, miss. That would be one green in regulation, or I could have gone miss, miss, hit. So there was three ways to hit the green in regulation. Let me phrase that properly. There's three different ways to hit the green in regulation once out of three holes. So what we'd say is from the three trials, we want one success. So three, choose one. I can tell you is three. There's three ways to do it. Okay, we had one success. So we would have gone down one of the green branches. So it's 11 on 20 to the power of 1, which is just 11 on 20. But we had two failures. So it's 9 on 20 to the power of 2. And chuck that in a calculator, you'll get approximately 0.33. Okay, we play a similar game with the next one. Now we're saying, all right, we want two successes. So you go success, success, failure. That would be two successes out of three holes. Or we could have gone success, failure, success. And the other option would be failure, success, success. So three, choose two would be three as well, because there's three ways to have two successes on three holes. Okay, that must mean we had 11 on 20 to the power of 2, because we went down the 11 on 20 branch twice, so we multiply that. And then we had one failure, so we must have gone down one 9 on 20 branch. So 9 on 20 to the 1. Chuck it in a calculator, you get approximately 0.41. And then finally, if you're getting the idea, I encourage you to think about what the probability of three successes is, but it will be this. From the three trials, we want three successes. So that must be 11 on 20 to the power of 3. It must have been we had 0 failures. So we went down no 9 on 20 branches. And chuck that into calculator, you'll get 0.17. And so now we can fill in our probability distribution. So X represents the number of successes we had. We had 0, 1, 2, or 3. And these are all our answers, which are just these answers here. Now this should all add up to 1, right? When you're playing golf, when you're playing three holes, you either hit the green in regulation 0, 1, 2, or 3 times. There's no other options, right? So all of these probabilities must add up to 1. If you get a calculator out and add them up, it's probably a little bit more than 1. That's just rounding errors. Okay, I rounded these and did approximate answers, but it'd be very, very close to 1. Okay, so gets a bit hairy when we talk about binomial distributions, but hopefully that example made some sense. I'll just maybe finish by saying this. If you're really keen for sort of the formal definition of the binomial distribution, we would say that the probability of x successes out of n trials is given by n choose x multiplied by the probability of success raised to the power of x multiplied by 1 minus p to the power of x. Now 1 minus p must be the probability of failure, right? Raised to the power of x. I don't think that's right. Sorry, one sec. Few changes on the fly there. This should have been n minus x. So n trials, x is the number of successes you want. So that tells you how many ways you can have that many successes. Then you can have the probability of success raised to the power of x. And then 1 minus p would be the probability of failure. And then n minus x must be the number of failures that you had. So x is the number of successes you had. N minus x must be the number of failures that you had. Because remember, it's Bernoulli, right? It's either true or false. All right. You can hopefully see why it might be called the binomial distribution as well. This is a binomial, right? Binomial meaning two terms. Anyway, I've spoken enough. Hopefully that clarifies things. Gets a bit hairy, but hopefully, yeah, you're making a bit of sense of it. Good luck.